Thank you, Avni, and thank you, sir. I hope the delegates have got mentally warmed up with this presentation and now they will easily grasp the upcoming lectures by our experts. Engineer Bidur Jha is M.Tech Transportation Engineering from IIT Kharagpur. He joined Lee Associates South Asia Pvt Ltd and is currently General Manager, Payment and Materials. He has altogether 19 years of professional experience and his core areas of expertise are investigation and evaluation of existing payments, material testing and characterization, value engineer design of new payments, and long performing rehabilitation and maintenance design of existing payments. Now I request Engineer Bidur Jha for giving his technical presentation on the topic overview of IRC 37 2018.
refreshing us the background of IRC 37. Good afternoon, one and all present here. Welcome you all to this topic, that is overview of IRC 3718. First of all, we wish a very happy birthday to Engineer Indrajit Ghai sir. Sir, we appreciate your proactive efforts for organizing such august gathering of highway fraternity, a mix of academicians, students and teachers, practicing engineers and researchers. To have pavement engineering environment atmosphere in this hall, we must remember father of pavement engineering in India, Dr. Pvt Ltd. Sir, you have left with us world-class design guidelines for flexible and rigid pavements. Sir, we remain always grateful to you. And for information to all of you, IRC 3718 is the last creation of Dr. Pvt Ltd. Outline of this presentation. First is purpose of this workshop, progression of IRC 37, guideline for design of flexible pavement, discussion on each section of IRC 3718, selection criteria of pavement layer combinations, long life or perpetual pavement, conclusions and way forward. Purpose of this workshop. Though while drafting IRC 3718, it has been tried to explain the basis of each inputs so that it will not remain black box for the practicing professional pavement design engineers. As principal, as secretary sir told, it is a two-way interaction. It is a two-way interaction to elaborate thick and thin lines, that is provisions of IRC 3718, so that after this workshop or interaction, we can design flexible pavement more professionally, with better understanding and with more confidence. The second objective is to identify or take feedback from practicing engineers regarding any inconsistency, ambiguity, so that it can be presented at appropriate forum, that is S2 committee of IRC 37, and if required, any corrigendum addendum will be issued for better clarity to the users. This progression of IRC 37, first it came out in 1970, and then first revision has done in 37, 1984. The second revision, IRC 37 2001, was semi-mechanistic or mechanistic empirical based on some analysis or some calculation, and that calculation validated with the performance. IRC 37 2001 was an exceedingly simplistic lookout pavement structure catalog for a given subgrade CVR 2 to 10% and design traffic 1 to 150 ms. Even a class 6 student can design flexible pavement. Dear friends, as all of you know that, or all of us know that, pavement construction cost constitute 40 to 70% of the highway improvement project. Therefore, we must give respect to this engineering structure. It is not empirical thing. We give the significance to this and we treat the pavement as an asset. We must give the importance of pavement design, construction with pavement design with realistic input parameter, construction within construction tolerance, and then maintenance as well to preserve the and to avoid this pavement disintegration. The recommended layer in IRC 37 2001 version was bituminous layers over granular base and subbase. IRC 3712 third revision, it is just like open economy or globalization of Indian economy in year 1991. So IRC 37 was the open era for pavement engineering in India. Design of bituminous pavement for traffic more than 150 MSA, use of new type of pavement materials, use of new construction technique and practice. Dear friends, these technology material are not new, not innovative. It is a proven technology and proven materials other side of the world. And technology doesn't know border. Subjected to if its appropriate traffic condition and climate will meet. It recommends the use of harder grade binder to resist rutting and top-down cracking in the upper bituminous layer and for fatigue resistant bituminous mixes for the bottom bituminous layer. Bituminous layer, fatigue cracking and subgrade rutting criteria given for two different levels, 80% and 90% of reliability. Fatigue criteria was also included for cement treated base. IRC 3712 gave a lot of positive input to the profession. However, there have been feedback about certain difficulties encountered during its implementation. There appear to be concern about possible under-designing of pavement based on the provisions of IRC 3712. The professional has exploited IRC 3712 like anything. They have done slimmer and slimmer pavement structure design in the shade of IRC 3712. That means they have misunderstood the provisions of IRC 3712 version. The fourth revision, with this background, the fourth revision, late Professor B.V. Pandey drafted the guidelines. A 3-member committee of Sri A.V. Sinha, Sri R.K. Pandey and myself worked further on the draft, and finally it was edited by convener of S2 committee, Dr. K.S. Reddy, and published on 22nd November 2018 at Nagpur IRC session. scope. This guideline deals with the design of new flexible pavement for traffic more than 2 MSA. Sir, please remember the fine point of this IRC 37. It is a guideline, it is not a code of practice. So it always encourages the users expected to use their skills, experience and engineering judgment, take into consideration of the local climatic condition, cost and availability of material, their durability and past pavement performance in their respective region for selecting a suitable pavement composition. That means it is not a code of practice. So the local practices, experiences always prevail over the provisions in IRC 37 2018 guideline. Please remember this. The failure modes of flexible pavement and their critical mechanistic parameter, subgrade rutting, it is controlled by vertical compressive strain at top of subgrade, bottom of fatigue cracking of bituminous layer. Dear friends, this bottom of fatigue cracking, distress mode and failure mode is only applicable for pavement with thin bituminous surfacing. I have never seen the pavement designed with IRC 37 2001 onwards. There is this type of pavement failure. That means bottom of fatigue cracking until and unless there is no great subsidence and consolidation. And third one is fatigue cracking of CTB by controlling horizontal tensile strain and bottom of CTB. Moisture induced cracking, bitumen rich bottom bituminous layer, or it will control moisture induced cracking in bottom bituminous layer. Top down fatigue cracking of bituminous layer, choice of binder and mix, rutting within bituminous layer, choice of binder and mix. This top down fatigue cracking, it is a typical failure modes of thick bituminous layer. And dear friends, we do not have the performance model and criteria specific to Indian climatic and traffic condition. So I request any department from Punjab, Haryana, whatsoever to take lead to develop the performance model, as we know that MORTH and NHI are inert for these things. That's why what Dr. Anuj has told, our pavement is failing. Failing because we have still not developed its mathematics or performance model. So we are controlling it till now by choice of binder and mix, rutting within bituminous layer. For your information, Dr. Sunil Bose sir, the eldest living student of Dr. B.V. Pandey, he is revising or writing a manual on bituminous mix design. So I request all of you to please give feedback to him so that he will make a robust bituminous mix design manual and we control such type of failure. After getting the mathematics of this, any pavement engineer can have a good sleep. Otherwise, they always get blamed. Reliability, that means probability of non-failure. It is recommended 90% reliability for all important roads, expressway, NH, state highway and urban roads. Other than for other category of roads, 90% reliability for design traffic 20 MSA more or more, and 80% reliability for traffic less than 20 MSA. This is performance criteria, subgrade rutting. We have allowed maximum up to average rut depth of subgrade, top 20 mm. More than this, we consider it a failed pavement, and this is the performance equation we have developed. And now we have controlled the subgrade failure. Rarely our pavement fails in subgrade rutting. Bottom of fatigue cracking of bituminous layer. When crack surface area is more than 20%, we consider critical or failure condition, and this is the equation what we developed for Indian condition. And dear friends, here the term used is volume, VBE, volume of effective bitumen. Though we are doing the design with consider this fatigue equation, with VVE, but we are never calculating and validating this VVE, whether it has achieved in actual design, DBM design or not. VVE is simply VMA minus VA, volume of mineral aggregates minus volume of air void. People are manipulating this parameter. So be careful. You must check VVE calculation in your pavement design while doing mixed design of DBM bottom layer. VVE is simply VMA minus VA. Performance fatigue cracking of CTB. There are two checks we generally do for CTB layer thickness calculation. One is fatigue cracking, and then fatigue cracking. And here you mind it, this epsilon T, that means horizontal tensile strain at bottom of CTB layer is epsilon T, and in this equation we take epsilon T in micro strain. People, please do not do mistake by taking the strain whatever come in your IIT PEP calculation, you take in micro strain. And for CTB layer, for other layer, we are taking the tire pressure 0.56 MPa in the structural analysis. We have to take 0.8 MPa for CTB layer. This is second check of CTB layer, that is cumulative fatigue analysis, similar to rigid pavement using this equation. This is analysis of flexible pavement. This is the standard condition we generally took. And this is the pavement model for structural analysis of a flexible pavement. It is a typical I have shown for bituminous layer with granular base and subbase, and you will find it in figure 3.1 to 3.6. It has been shown how to do a structural modeling for analysis of flexible pavement layer combination. Okay, sir. Now, selection of pavement layer combination, though it is missing in this guideline, but based on some experience I will share with you. Selection of appropriate layer combination generally being selected on the basis of performance of the typical layer combination in the project road vicinity. That means if this Delhi-Gurgaon road from Gurgaon-Jaipur road, Delhi-Jaipur road, from Jaipur to Gurgaon or Delhi, it is failing, severely failing. After so many maintenance, it is rerouting, and the typical pavement layer combination is bituminous layer over granular base and subbase. So while designing the project in that vicinity, we never recommend or we never go for that layer combination. Along the approaches, that means we are experiencing this failure of ever rigid pavement on approaches of the structure having a steep longitudinal gradient. So we never thought rigid pavement along the approaches. Then design period, that means if the design period is less than 20 years, we go for flexible pavement. If it is 30, we this rigid pavement, more than 30, we go for long life and perpetual pavement. Even for design period 30 years, to restrict initial construction cost, we have gone for this flexible pavement stage construction. While in other projects, to reduce this life cycle cost and maintenance cost, we have gone for rigid pavement. And concessionaire and contractor preference. What are their planning, what are their thoughts, we must consider while doing selecting appropriate pavement layer. Reuse, recycle of RAP generation. That means if in our project there is some RAP generation, we must reuse it. Don't waste. Availability of material at economic haulage, use of locally available materials. We always encourage to use of locally available material and material availability at economic haulage. Environmental legal regulation. That means if in urban area HMP is banned, then we must thought of some cold mix bituminous layer. availability of machinery and plant. If we are thinking for CTB and CTB as layer, but we do not have purpose with soil stabilizer, we don't go it for, because we use the layer combination, we use the optimum pavement layer combination with having this purpose-built machinery and plants. If we go for RAP use more than 30% in DBM mix, we must have double barrel HMP plant. We don't do the things with Jugaad system, otherwise our pavement will fail prematurely and everybody will blame. And then extra loading, design traffic, subgrade CBR, rainfall. If we are designing the pavement in Cochin, then we must go for more granular layer, having this separate filter layer, GSB filter layer and GSB drainage layer. So these are all the things we have to holistically think before selecting an appropriate pavement layer combination. Though there will be several combination of layers, in Delhi Hapur Expressway, I have used one layer combination with GSB, CTSB, WMM, which is not specified in IRC 3718, and it is performing well. So there will be several n number of permutation and combination for selecting pavement layer combination for base sub-bases. What IRC recommend 6 types, GSB, WMM, DBM, BC. Appropriate selection situation for widening if existing pavement and GSB, WMM, DBM, BC to make it compatibility for stiffness and drainability. CTSB, CTB, granular crack relief layer, DBM, BC. If design traffic is more than 150 MSA, then we must have CTB layer in our pavement layer combination. CTSB, CTB, SAMI, DBM, BC, design traffic more than 150 MSA, and also aggregate lead is more, so that we can preserve the aggregate required for GCRL. Then CTSB, RAP, DBM, BC to use RAP generation, GSB, CTB, GCRL, DBM, BC, high rainfall and design traffic more than 150 MSA. CTSB, WMM, DBM, BC, subgrade CBR is low and aggregate lead is more. And also if there is more extra loading, we must go with this combination. See, it is individual choice. It varies from person to person. So this typical pavement layer selection in one project itself, I have gone for different pavement layer combination. That means for main carriageway, other than approaches, we gone for rigid pavement. As poor performance of flexible pavement under prevailing overloading, so we gone for rigid pavement. Main carriageway approaches, we gone for flexible pavement with CTSB, WMM combination, because even poor performance of rigid pavement along approaches and is very sensitive to the expected and desirable settlement of new field approaches. Main carriageway, new construction, reconstruction, CTSB layer, and main carriageway widening, we have gone for this WMM GSB conventional thing to make it compatible with existing pavement layer. Slip road, service road, we have gone for 3-layer combination, conventional, RAP, WMM, CTSB, GSB, so that we can reuse the things, RAP generated thing. Toll plaza, for durability consideration, we have gone for rigid pavement. So, dear friends, there is no cookbook available where it has been described that you select this layer. You have to use your engineering judgment and experience. Design period 20 years for NHSS urban, 15 years other road, 30 years for high density corridor, 300 MSA and more, and expressway. This new things has come. Design traffic for a stage construction, 1.67 times of the stage 1 design traffic. That means, dear friend, what happened in earlier, we are doing a stage construction for 10-year design period. Bituminous surfacing for 10-year design period, and we are planning to do the overlay after 10 years. But to have some remaining life, prior to overlay, this new things has come in our guideline, so that the existing bituminous layer will not exhaust entire stage 1 life prior to its rehabilitation. Vehicle damage factor, IRC 37 strongly recommend to take the realistic prevailing VDF based on axle load survey. Please do that, because all the designers generally manipulating this VDF. They are under designing the pavement to save the cost. With this new Gazette notification, we have revised this indicative VDF in our guideline. Now it is 5. This section 6 subgrade, the difference between the bottom of subgrade level and the level of water table high flood level should be generally not less than 1 meter, bottom of subgrade. If there is a existing road and no overtopping is reported, it has to be 0.6 meter. Laboratory CBR test, though IRC 37 recommends a static compaction, but as we are designing the pavement considering effective resilient modulus of subgrade, which is after correlating this CBR with MR value, and that correlation itself has been developed with dynamic loading condition. So for laboratory CBR test, it can be either static or dynamic, it doesn't matter. Minimum surcharge weight, we have to keep 5 kg. It is always a dispute in the field. So rationally it has to be equivalent surcharge weight of pavement layer. That means pavement layers over subgrade, which is coming around 20 to 25 kg depending upon the pavement layer thicknesses. But to have some factor of safety, we take minimum 5 kg. Minimum 5 kg. It will give some factor of safety. This design is based on effective resilient modulus, calculating using effective subgrade CBR, considering 4 days soak CBR at 97% MDD of 500 mm select subgrade and 4 days soak CBR at the rate of 95% MDD of in situ soil, embankment soil, 500 mm layer below subgrade. That means with this 2-layer system, we calculate the equivalent single layer system. This input is due to Lee Associate. While we are doing the design in 2000 in Nagpur, then Dr. S.K. Rao, who has with Lee Associate, he told Professor Pandey, very peculiar professor, if we put 10% CBR material on 2% CBR embankment soil, does it rational? Then Dr. Pandey thought the things, and with the help of Amarnath Reddy, he has developed this model. Effective subgrade CBR, this is deflection. We calculate the surface deflection of 2-layer system, and then we calculate E equivalent of single layer. The effective subgrade CBR should be more than 5% for roads estimated to carry more than 450 commercial vehicles per day. This is the correlation which has been developed with dynamic conditions. For the purpose of design, the effective resilient modulus shall be limited to maximum value of 100 MPa. In so many projects in Rajasthan, the designer has taken even 22%, 24%, 28% CBR. So they have exploited IRC 3712 like anything. So now it has been restricted to 100 MPa. This is the Poisson ratio value. Granular unbound subbase, filter layer, separation layer, the bottom layer, top layer is drainage layer. Subbase layer has to be both the subbase layer, not in some of the typical cross section you will see only one layer is extended. So both of the subbase layer has to be extended to full formation width, that is even under median and earthen shoulder. Minimum thickness of single layer subbase 150 mm. minimum thickness of each layer of 2 layer subbase is 100 mm. If total subbase thickness is less than equal to 200 mm, it has to be laid in single layer, and MORTS table 401 grading 5 or 6 has to be adopted. If both subbase thickness is, if total subbase thickness is more than 200 mm, MORTS table this grading 1 or 2 for lower subbase and grading 3 or 4 for upper subbase layer has to be adopted. Calculation of resilient modulus of granular layer, that means this is the equation, well-known equation, and this is the thickness of granular layer. If it is single layer subbase, then it is a single layer subbase. If we have granular base and subbase both, then it is the total thickness of base and subbase. This is the effective subgrade modulus. Cement treated subbase, CTSB layer. So, as we all know that with CTB layer, the permeability is getting reduced. So, we have now recommending grading 4, table 401 of MORTS, so that neither strength nor drainage is getting compromised while using CTSB layer. CTSB modulus 600 MPa if lab 7-day UCS of cube specimen. Mind it, there is always some dispute whether it is cube or whether it is cylinder. It is a cube, and to have some factor of safety 1.5 we have given. In the lab we must get 1.5 times 123 MPa of cubical specimen. And if this UCS is in the range of 0.75 to 1.5 MPa, we take this CTSB 400 MPa, and it is being recommended for traffic less than 10 MSA. And field curing has to be done for minimum 3 days. Then WMM unbound base layer, thickness 150 mm, except when used as granular crack relief layer over CTB, its thickness has to be greater than equal to 100 mm. For the granular base placed on CTSB layer, the resilient modulus may be taken as 300 MPa if it is natural gravel treated CTSB. If it is crushed rock treated CTSB, then we have to take 350 MPa. Now one new thing has come, this geosynthetic reinforced granular base and subbase. Dear friend, now this 2 and 3rd August Goa midterm IRC council meeting, it is IRC SP 59 geosynthetic guidelines is going to be published. So be careful while doing the design with geosynthetic reinforced subbase and base. And these are the provisions in the IRC 3718. Case 1, over subgrade only geosynthetic reinforced subbase is there. Then this is the equation we use to calculate resilient modulus of subbase layer. Over GSB only geosynthetic reinforcement base, then we use this equation to calculate reinforced base resilient modulus. This LCF or MIF, that layer coefficient factor, or MIF, modulus improvement factor, that means if we use this geogrid reinforced subbase and base, then its layer coefficient ratio, LCR, layer coefficient ratio is getting increased by more than 20%. If it is geocrete, if it is geocell, then it can be even 1.6. So be careful while using this reinforced subbase and base. Dear friends, be careful, but don't fear to use any combination given in IRC 37, because we have to preserve the environment. Over subgrade, both GSB and base are geosynthetically reinforced, and we use this equation to calculate this effective composite modulus, resilient modulus of reinforced base and subbase. Cementitious bases CTB grading is table 400-4. We take the resilient modulus 4000 MPa, lab 7-day UCS cubical specimen this range, thickness must be greater than equal to 100 ml. Field curing we have to do minimum for 7 days. Flexural strength, modulus of rupture of CTB material. That means, see, there are three terms. Don't get confused. One is modulus of elasticity or Young modulus, which we taught in our strength of material lecture in engineering. It is axial stress by strain, E. Then the second term is flexural modulus and flexural strength. That means bending divided by strain, bending stress by strain. And this resilient modulus, it is deviator strain divided by recoverable strain, because our pavement is viscoelastic. So we always have some elastic and plastic recoverable or permanent strain. For CTB, one has to do this durability checking also for CTB layer also. Crack relief layer, its thickness has to be greater than equal to 100 mm and resilient modulus 450 mm. And SAMI, stress absorbing membrane interlayer. It is nothing but a spreading of prime coat like quantity of modified bitumen and blended with some coarse aggregate. Sorry. For the pavement analysis, the SAMI layer is not considered. This wrap, VG 30 bitumen is recommended. Minimum curing is 3 days. And mixes for surface core, it is clearly given in IRC 37. We have to comply those things. And this mixes for base and binder courses, separately provisions is specified. For binder also, we have this separate thing for selection of binder for base and surfacing. And for national highways, VG 40 for DBM, even if the design traffic is less than 20 MSA. And VG 40 bitumen must have 30,000 poise viscosity at 60 degrees Celsius. The thin bituminous layer, PMC, PS, MSS and SD shall not be considered as part of the bituminous layer for structural analysis. The one more thing, resilient modulus of bituminous mixes. That means the resilient modulus, we must assign the modulus of surface layer same as that of the DBM layer. Because in the lab it is less, but practically it is more. It is less in the lab due to larger recoverable strain. The modulus we select corresponding to 35 degree temperature, annual average pavement temperature. In the field we calculate resilient modulus with ITS. Now this mixed volumetric of bottommost DBM layer. Case 1. Pavement with BC over single DBM layer, air void for lab design of DBM layer 3.5%, volume of effective bitumen has to be calculated, VFB limit is 80%, pavement design with VA 3.5 and calculated VV in field DBM layer compacted to minimum of 95.5% GMM so that in situ this BC layer has to be designed and laid as per prevailing specification. Pavement with BC over more than one DBM layer. Air void for lab design of bottommost DBM layer 3%. Volume of effective bitumen calculated. Pavement design VA 3%. VV with calculated VV. In the field we have to compact less than equal to 4% in situ air void. The BC layer and DBM layer other than bottommost DBM layer shall be designed and laid as per prevailing. specification conventionally. Even in the case the parameter indicated above for rich bottom mixes are not achievable for any reason, actual air void achieved and corresponding effective binder volume are to be used for estimation of fatigue life pavement design. And the minimum thickness of bituminous layer for traffic exceeding 20 MSA for pavement having CTB layer must be more than 100 mm. Now this long life and perpetual pavement, see entire this Delhi Vadodara Greenfield Expressway has the provision, has been designed for long life perpetual pavement. So these are the feature of perpetual pavement. It is based on the perpetual pavement design requires defining the endurance limiting strength below which structural damage does not accumulate over an infinite number of cycles. The adopted fatigue endurance limiting strength and structural rutting endurance limiting strengths are 80 micron and 200 micron. And these are the typical layers. See, dear friends, in the agreement of those packages is given DBM, but they have not specified this bitumen rich bottom bituminous layer. But we have to do the design professionally, and we consider this fatigue resistance MHA, rut resistant intermediate layer, and rut and top down fatigue resistant SMA layer. So we always do the things as per engineering judgment. These are the construction and conclusion and way forward. Do the flexible pavement design as per procedure, more procedure of IRC 37, more professionally. Please do not temper the realistic inputs, otherwise pavement will prematurely fail, as no one can hide anything inferior under the pavement. If there is something wrong, as the pavement is directly exposed to the nature and traffic loading, definitely it will fail within 6 months or 1 year. Document the experiences and share the feedback with IRC for further fine-tuned revision of IRC 37. Questions? Thank you. Thank you for your patience here. Sorry.
Thank you, sir, for the detailed deliberations on IRC 37/2018. Any questions, please, from the audience?
Sir, minimum CVR, subgrade CVR for perpetual payment. Sir, perpetual payment we are going to design to last 50 years. So it will last 50 years. And dear friend, this subgrade, granular base and subbase are irreversible layer. That means without reconstruction we cannot add the deficiency in it. So it is prudent, if things are available, we must go so that we get the effective CVR of subgrade 15%, because the one fine point here written is unyielding subgrade platform, unyielding subgrade, and in future we cannot add. So though it is given in the EPC agreement 8%, please don't go with that. We always recommend to go up to the maximum limit.
Question would be coming down, if your soil is CPR 8%, so can you do with 8% or you still need to modify?
Sir, it is simply mathematics. We can do with any CBR. With 2% also we can do, because we have to keep the strain within 200 micron. But it is always better and suggested and recommended to go for maximum whatever you can achieve.